All right, so last week, you were given a list of 10 polyatomic ions that I told you guys that I wanted you to start getting familiar with them and learning their formula as well as their name. And it seems as though you guys have done a really good job with starting to memorize those, which is awesome. What we're going to start today's lesson with is by taking a look at how we can manipulate the formula of a polyatomic ion and how that manipulation changes the name of the polyatomic ion. So we're using these 10 basic polys to start with. There are a few different things that we can do to that basic polyatomic ion, the 10 different ones that we've been working with so far. So the first thing we can do is we can decrease the number of oxygens in the formula. And we're going to take a look at what happens when we decrease the number of oxygens by 1. And then again, what happens when we decrease the number of oxygens by 2. The second thing we can do to the polyatomic ion formula that we've been looking at, those 8 ATE formulas that we've been looking at, is we can actually add in an extra oxygen as well. And then the last thing we're going to look at is what happens to the formula when we add in a hydrogen. So the first things we're going to do is manipulate the oxygen numbers and then manipulate by adding in a hydrogen. So what happens to the name of the polyatomic ion when we decrease the number of oxygens? So the first one we're going to look at is just decreasing the number of oxygens in the formula by 1. And because when we decrease the number of oxygens by 1, we change the formula, we have to have a different name for the new ion we're creating. So we've got two examples we're looking at on the screen right now. We've got SO4 2- and SO4 2- for sulfate and NO3- for nitrate. If I decrease the number of oxygen in sulfate, my new formula is going to be SO3 2-. Notice the charge of the polyatomic ion does not change. The only thing that we're changing is the number of oxygens. When we take an oxygen away from that basic formula we've been learning, we have to change the ending of the polyatomic ion. So we change the ending from 8, that ATE ending, to ite, ITE. So SO4 2- is sulfate. SO3 2- is sulfite. We see that again when we take a look at the second example with nitrate. We have NO3-, the formula we've already been working with. But when we take that one oxygen away, we get NO2-. Again, the charge does not change here, just the number of oxygens. And so we have to change the ending from nitrate to nitrite. So here we're looking at the same two examples again. We've got sulfate and nitrate, the polys that we've been working with. If we take 2 oxygens away from sulfate, we now have a new polyatomic ion known as hyposulfite. So we still have that ITE ending that we were looking at on the previous slides, but now we also have to add in a prefix, hypo. So we've got hyposulfite. Same thing for the nitrate ion. If we take 2 oxygens away from that original polyatomic ion formula, that NO3-, it becomes NO- with no subscript. We've got just 1 oxygen left. And so we have to change the name to hyponitrite. So anytime we're losing oxygens, we're going to be looking at that ITE ending. It just depends on how many oxygens we've lost. So losing just 1, you just change the ending. If you lose 2, you have to change the ending and add in that prefix of hypo, hyposulfite, hyponitrite. So we've taken a look at what happens when we decrease the amount of oxygens by 1 or by 2. Now we're going to take a look at what happens when we increase the number of oxygens. So we can add in oxygens to those polyatomic ions the same way that we can take them away. And when we add in an oxygen to that base formula that we've been looking at, we're going to keep that 8 ending, the ATE ending, But now we have to include a different prefix. So when we increase the number of oxygens, we're going to use the prefix per, P-E-R, to indicate that we've added in an oxygen. So taking a look at, again, the same two examples, we've got sulfate with SO4 2-. When we increase the amount of oxygens, we've got SO5 2-. Again, noticing that the charge of the polyatomic ion is staying the same here. Same for nitrate, we've got NO3-. When we add in an oxygen, we have to change the name from nitrate to pernitrate, NO4-. That extra oxygen changes the prefix of the polyatomic ion. So adding in a hydrogen is a little bit more complicated than changing the amount of oxygens, because when we add in a hydrogen, not only are we changing the name, but the charge changes too. So that's something that's unique about adding a hydrogen into a polyatomic ion. So here we're going to look at that sulfate ion again. Starting out, we know that the formula of sulfate is that SO4 2-. When we add a hydrogen to the sulfate ion, there are actually two different ways we could name that ion. So the first of them is known as hydrogen sulfate, so indicating that you've added a hydrogen to sulfate. Or if you'd like to, you can even abbreviate it to bisulfate. So either of those two names would be acceptable for the polyatomic ion where we have the hydrogen added to sulfate. When we take a look at the charge, we see that the sulfate ion has a charge of -2, but the bisulfate ion has a charge of -1. So adding in that hydrogen actually is the same as adding in a positive charge to the polyatomic ion. So we would do the charge of the poly originally, that -2, which is what we're looking at the math problem at the bottom. We've got -2, which was the charge of the original poly, plus 1, because we're adding in a positive charge when we add hydrogen to give us a new charge of -1. So that is why the charge on that bisulfate ion increases by +1. All right, so now that we've taken the time to learn how we can manipulate our polyatomic ions, we are going to look at how those new formulas are related to naming acids, our last type of ionic naming. When we take a look at acid naming, all acids have a hydrogen in them. That is what makes them acidic. And there are two different categories to acids. We have when the hydrogen bonds to just a single ion, which is, we've got some examples there where we've got HBr, HF, and HCl. Or we can have when a hydrogen bonds to a polyatomic ion. So we've got two categories of acids that we're looking at, and unfortunately the naming for those two categories of acids is slightly different to indicate whether or not it's bonded to a poly or bonded just to one element. So we're going to start easy. We're going to look at how the hydrogen bonds to a single anion. So when the hydrogen is bonded just to one other element, to an anion, you are going to use the prefix hydro, H-Y-D-R-O, which is different than the prefix hypo. I know they sound very similar, but hydro is the prefix we use for acids. And then you would keep the root name of the anion like we've been doing, and you're going to add ic, I-C, at the end. So if we have that first example of HBr, where hydrogen is bonded to bromine, we would call that acid hydrobromic, IC, acid. Is looking at how hydrogen can bond to just one anion and how we would name those acids. Remember, our second type of acid was when hydrogen can bond to some polyatomic ions. So let's take a look at what happens to the name when it bonds to a polyatomic ion. So there are two different endings to our polyatomic ions. We've got the 8 endings, the ATE, where we could have, for instance, perchlorate or chlorate. And we have the ite endings, where we could have chlorite or hypochlorite. So we've got two different types of endings. Depending on the polyatomic ion that the hydrogen is bonded to, the name of the acid changes. So if we take a look at sulfate, if the hydrogen was bonded to sulfate, we would change the ending to ic. So sulfate would become sulfuric acid. If we were looking at an ite ending, we would change it to us. So sulfite would become sulfurous acid. One helpful hint that I've used in the past to remember the difference or how to change the names is that if I ate it, it would be icky. So if I ate the acid, it would be icky, ate, ick. Or I only bite, ite, into delicious foods. So again, you can use those sayings if you want. I have found that they help with trying to memorize the difference for when I use each ending. All right, let's take a look at how we write the formula given the acid name. So we are going to be doing the same thing with acid naming that we've done with all of our other types of naming. The charges on the polys and the charge on hydrogen are important. So looking at hydroiodic acid, that prefix hydro tells us we're looking at just one element bonded to hydrogen. So we would have hydrogen, which has a charge of +1, bonded to that element iodine with a charge -1. When we crisscross those charges, we get 1 and 1 as our subscripts. And so our final formula would be HI. Those are pretty straightforward. When we take a look at one that includes a poly, it's really important to understand those endings, those suffixes. So if we were given the polyatomic ion or the acid chlorous acid, we know that the hydrogen in the acid is bonded to chlorite. And we know the formula for chlorite is ClO2 -1. So we would crisscross those charges. There's a typo here too. And you would get H1 ClO2 1. Ignore that I, I'll fix it. And when we combine those, we end up getting HClO2 as our final formula. So that saying one more time to help us, if I ate it, it would be icky, or I only bite into delicious foods. Ite, us, ate, ick.